All right, we did have a few homework questions in 2.4 that I wanted to address. Here's 2.4. I actually had number 8, 9, and 17. So I just want to take a look at those particularly here. So look at this one here, 2x less than or equal to 9, and write the solution using. This says inequality notation, so kind of be careful how you write that in, okay? So just a few things here. Okay, that was number 1. What the issues were here was number 8. So how do you solve this one? 5 minus 1/4 x less than 1/4 x plus 1. All right, rewriting it here so we can actually use it right over here. So notice real quick here you have these fractions here. So whenever you have fractions, you probably want to figure out how to get rid of them here. And the best way to get rid of them is just to multiply by the common denominator. In this case, this is 4, this is 4. So let's just multiply this side by 4, and let's multiply this side by 4. Okay. A quick little thing when you're multiplying by 4 to get rid of fractions, it's a lot easier just to multiply by every single term. So notice 4 times 5, there's no denominator there, that's just going to be 20. Don't forget the minus sign here. This 4 and this 4, they're going to cancel each other out because that's exactly what you want to do. So as you multiply 4 times 1/4, again, these 4s are going to cancel, leaving you just with x. And 4 times 1 is just 4. So still kind of moving across to get what we want here. Let's get x's on one side. So that's going to cancel these out. So it's 20 minus 2x less than 4. Let's move this 20 over to this side. So negative 2x less than negative 16 looks like. And when you divide through by negative 2, remember, don't forget, it is going to change the inequality. Multiplying through or dividing through by a negative number switches your inequality. So that's the other issue students sometimes have with this problem. So we're going to graph x greater than 8, and we also have to write as an inequality. All right, writing this as an inequality here, we will say x. Now we have to greater than. There's a greater than inequality on your keyboard if you want to use that. If not, you can always just go here, and there's your inequality sets right here. So less than, greater than, that's what I want. I want an 8 in here. Now I want to click save. So there it is. You could also enter it as that. Okay, so now we're going to look for this guy here. So we have a line segment, but we have a choice of a dot or an open dot. Technically, this is your closed dot. So x greater than 8, which means I'm going to have an open dot at 8. So I'm going to have to write that in. Then I have a line segment. And as you draw this, make sure you can take it all the way to the end, because when you take it all the way to the end, you're going to have these little arrows appear. Once you see the arrow appearing, that's cool. That's exactly what you want. You're saying that this guy's going to keep on going and going and going to the right-hand side. Okay, preview this just to make sure that's what I want. Yes, that's what I want. There's my graph of it. And let's submit this to see if I am correct. Ooh, something is incorrect here. So going back over here, it says that this is just fine and dandy. X greater than 8, that is true. I got my answer correct. The graph is saying no, this is not correct. So clear. So open dot. Right, let me just see if this is gonna. Okay, let me submit it one more time. Having a little bit of space right there. Adding a little extra space there. Okay, let me try one more time. This is my last attempt here. Let's see. Open dot right at 8. The line, so we're going to put right on 8 and extend it out further this way. Whoa, okay. I want to show you where I got sort of. So really, the whole concept is just to make sure it does hit right at 8. And when you make that number line, make sure you start the number line right at that 8. What I was doing is I was starting it just a little bit, almost like a hair past 8, and it was telling me I was wrong. So hopefully that helped. All right, number 8 is done. Number 9 is the next one to be done. Again, your problem is going to be very similar, not exactly the same as this, but solve the following inequality. And of course, we got to graph this again. So let's see what happens here. So 1 minus x over 5 greater than 2 minus x over 3. Again, we have fractions on our hands. Let's get rid of them, multiplying through by the common denominator. In this case, it's going to be 15. All right, brought it over to a little palette that I can actually work with. So notice the 3 and the 5 here. Those are my fractions, therefore my common denominator is 15. Let's multiply both sides by 15, or even better yet, I could write it like this. But even better yet, I'm going to do this. I'm going to multiply everything by 15, or every single term by 15. A lot easier to do that than sort of seeing the distribution of 15 across. Okay, so 1 times 15, that's going to be 15. This one, again, the whole concept of multiply by 15 so we can cancel off that 5. That makes it 3 this time. Don't forget about this little negative. That messes up students here too. So it's negative 3 times x, or minus 3x. All right, 15 times 2, no problem, that's 30. And again, this 3 cancels off. This becomes a 5, and we got ourselves a negative 5 times x. Negative 5x. Or minus 5x. Okay, let's bring things over. So adding 5x to both sides this way. That cancels, so this is 15 plus 2x greater than 30. Let's see, subtracting 15 from both sides. Sorry, that didn't look right here. So minus 15, minus 15. That's canceling, gives me that. And that's going to be 30 minus 15 is actually 15. Okay, divide by 2, divide by 2. And I get myself x is greater than 15 over 2. All right, or really what's going to happen is as I graph this here, 2 goes into 15 7 times and 1/2. So which one to put? This is the one you want to put for your answer right there. But when you're graphing, you want to think that 7.5. All right, let's return to our problem on XYZ. All right, let's put this in here. So I'm going to use the math palette here. We have x greater than, so inequalities greater than, and that's going to be 15 divided by 2. All right, save. Okay, then this is going to be 7.5. So here we go again. Open dot. I click on open dot. I'll click right on that 7.5. Make sure you really put it in right into there. Line segment has to start right at 7.5 and extend out. Again, wait for that arrow to pop up. That's cool. Okay, let's submit this to see if we are right. Yes, finally all greens here. Good. Finally know how to do this stuff. All right. And the last one here for this section that was given is number 17 that people had trouble with here. Number 17. Okay, so it says solve the following continued inequalities. Use both a line segment and interval notation to write the solution set. So you want 2 things here. So let's see. T minus 2 less than negative 2, or t minus 2 is greater than 2. Okay, let's see what in the world is that going to look like. So let's work it out. All right, so again, there's kind of 2 different pieces here if you want to just kind of write a little line here. So we're solving this one, the or statement coming across here, or that. So in this case, I'm going to add 2 to both sides. So we're looking for a t value that's less than negative 2 plus 2. That's going to be a 0. So that's that one. That's done. T minus 2 greater than 2. If I add 2 to this side because of the opposite sign, I'm actually going to get t greater than 4. So just as a little graph before I make the actual graph, I'm saying at 0, t is less than 0. So I'm going to do open dot at 0, and I'm going to go to the left. On the other hand, t greater than 4, I'm going to have an open dot at 4. I'm going to go greater than, so it's going to go off to the right. Again, going off that way. Okay, so I've solved it. I've done it. Now let me input it. All right, so open dot. Right at 0. We can do this already here. At the same time, we can put open dot right at 4 as well. Line segment that starts right at 0, right inside that little circle, goes off to the left. Again, that line goes off to the right. That's what I had in the previous one. Okay, and this one says solve the following inequality. We solved it. Use both a line graph and interval notation. So careful over here. This guy has to be interval notation. So I'm going to open it up. I have to open up a parenthesis here. Let's see, intervals. Yeah, there we go. That's what I'm looking for. So I'm going to go interval there, negative infinity, and I'm going to go to zero. And there's going to be a union there. And then I'm starting off again at 4, and I'm going off to positive infinity. That's what I want to see. Save that. So negative infinity to 0, and then at a little beyond 4 to positive infinity. Again, check that, make sure it's exactly what I want to say. That is, let's submit it and see if we are okay. Yes, all greens, perfect. Okay, so that was the answer to that.